Okay, so in this question we're having a look at an object that moves and we're given its acceleration in terms of x. So the first part asks us to prove that the velocity is given by a half e to the minus 2x. So since the acceleration is given to us in terms of x, we need to use the fact that acceleration is the derivative with respect to x of a half v squared. So we know the derivative with respect to x of a half v squared, we know that that equals minus a half e to the minus 4x. So to get the velocity, what we do is we integrate both sides, and that gives us a half v squared equals the integral of minus a half e to the minus 4x dx. And of course we can take the half to the right hand side by multiplying both sides by 2. And then all we have to do is integrate to get an expression for v squared. So we've got v squared equals 2 times minus a half. Just make that minus 1, so put a minus out the front. E to the minus 4x dx. And then we integrate the expression and we get a quarter e to the 4x. Sorry, e to the minus 4x plus c. And then we need to find the value of c. So we're told that initially x is 0 and v equals a half. So we substitute those in and we get a half squared. So that's a quarter equals a quarter e to the 0 plus c. Of course e to the 0 is 1, so we get a quarter equals a quarter plus c, and that gives us the value of the constant as 0. So now we know that v squared equals a quarter e to the minus 4x, which means that v is plus or minus the square root of this. And the square root of a quarter is a half, so it's plus or minus a half. The square root of e to the minus 4x is e to the minus 2x. And we know that when x is 0, v is a half. So we know that the velocity is positive. So we say that, but when x is 0, we know that the velocity is a half. Therefore, the velocity is a half e to the minus 2x. And that's part A. Okay, next for part B, we need to find the displacement as a function of time. Well, whenever we want to find displacement as a function of time, all we need to do is swap v with dx dt, because velocity is the rate of change of displacement with respect to time. So we swap those around and we get dx dt is a half e to the minus 2x. And then all we do is take the reciprocal of both sides. So if we do that, we get dt dx equals 2. It's going to become e to the 2x. Sorry, that's an x there. Then we separate all the t's to one side, all the x's to the other. And we integrate both sides of our expression. On the left hand side we get t, and on the right hand side we get e to the 2x plus c. Now we know initially it's at x equals 0. So we know that when t equals 0, x is also 0. So we substitute these in to find the value of c, and we get 0 equals e to the 0 plus c, and that gives us 1 plus c. So we know the constant here is minus 1, and then t equals e to the 2x minus 1. Okay, so I'm going to now make x the subject of this equation. So I'm going to take the minus 1 to the left hand side, and that'll give me e to the 2x equals 1 plus t. And then we take the log base e of both sides, and that gives us 2x equals log to the base e of 1 plus t. And we divide both sides by 2. So now we've got an expression for the object's displacement in terms of time. Okay, for the next part, the question asks us how far does the object travel in the third second. Well, if we wanted to know how far the object traveled in the first second, we'd find where the object was at x equals 0 and then where it was at x equals 1 and look at the difference between the two values. If we wanted to find how far the object travelled in the second second, we'd look at where the particle was at x equals 1 and then where it was at x equals 2 and find the distance. But the difference, But in this case it asks us how far it travels in the third second, so we're going to find the position at x equals 3 and the position at x equals 2 and have a look at the difference between those two values. So at x equals 3, the particle will be at a half ln 1 plus t, so that gives us 4, and at t equals 2, it'll be at a half ln 3. And of course, we can simplify that a little bit. We can write it as a half outside of ln 4 minus ln 3. And then, using the log laws, we can write this as ln 4 over 3. Part D asks us to have a look at what happens to x and v as t increases without bound. So, as t gets very large, as t approaches infinity, well, the velocity is going to approach a half e to the minus 2 times infinity, so a half e to the minus infinity. Now, e to the minus infinity, this is a very small number close to 0, which means that the velocity is going to approach 0. And it also asks us what happens to x as t approaches infinity. So if we have a look at our expression for x, we'll get, well, as t approaches infinity, x is going to approach a half ln 1 plus infinity is infinity, and so x is also going to approach infinity. This number just gets bigger and bigger. And part E says describe the motion. Well, the particle we can see is going to continue to move to the right, but it's going to slow down as t approaches infinity. So we just say the particle is always moving to the right, always moves to the right, and slowing down. So it's moving to the right and always moves to the right and is slowing down. And that's it. Thank you.